Hey there, Natalia, Vasily.
Hi.
How's it going? Yeah, I've just seen that you're in Barcelona and Vasily is in Tallinn, right?
Yes, that's right.
So that's awesome times when we don't have to make this long way to the conference to make a talk and to have some discussion, but still it's a bit pity that we can't meet in person. So Natalia, how are you doing now in these tough times?
Well, I am doing great, but I'm really sorry I cannot travel to Russia. It's a country I really love, and it's very close to my heart because I've been, married to a Russian for 18 years. So my children are also half Russian, and yes, or it's a culture I'm really close to. My Russian is not so good. I can understand it, but not speak it that well. But yes, I am super happy to be here.
Oh, that's I just wanted.
Italy.
Yes, I just wanted to ask if you are going to make a talk in Russian, but no, okay, maybe next time, I guess.
Not this time. Maybe next time. Yeah.
So Vasily,
But
how are you?
I understood your presentation.
Yeah, how are
Super
you
good.
doing, Vasily?
Well, I'm fine, and actually, I also said about the fact that I can't go to Russia. I have been there just 2 times, but I like the country. And by the way, Natalia, if you want to try, we can ask questions in Russian if you are risky enough.
No. I don't think my
No,
Russian is that good at a technical level. No. No,
but it's
but
never
next
late to
time I
train it.
promise.
Okay.
No, yeah, but it was
we
really good
have
that
it on record.
Yeah, I'll keep my promise.
Okay.
Okay.
So, Natalia, I've got a small question for you to start a small talk. We are going to speak about large-scale enterprise monoliths to be to be separated into different micro frontends. What does mean large? So, at what scale do you start? Do you need to start thinking about building micro frontends? How do you measure that? I guess that's the first question, and then we go to your talk.
I think what we are going to talk about right now is also how we got to monoliths, right? And at which point everything started a little bit falling apart or breaking apart, and not only from a technology perspective, but also from a team perspective. And how at an enterprise level, you have to sort of also consider the schedules of theirs, because these enterprise platforms serve the purpose of probably marketing a product or reaching out to clients, and then you have different business units and they all have different needs, and this is when we need to start breaking apart and probably going into a micro architecture in a sense.
Got it. Thank you. So, Natalia, Vasily, let's start the talk, I guess. Have fun and good luck.
Thank you very much. So,
Yeah,
hello and good morning from Barcelona again. I am very excited to be at this conference. Let me tell you a little bit about myself. So my name is Natalia Bendito. I've been introduced already. And 20 years ago, I was actually a designer, like a graphic designer. Before that, I even studied to be a buildings architect. So that knowledge serves me very well today, because I went from being a graphic designer to then becoming a web designer and then becoming a web developer. It was like an organic road into the role I have today as a solutions architect, with a strong focus in front end. But I am also a bit obsessed with the universe, and maybe someday I will become an astronomer. I don't know about that. Sometimes you have to be a little bit flexible and follow your heart. So, like I said today, after having spent several years as a technical lead, I have led teams of up to 40 developers into building large scale or enterprise scale platforms and projects. I spend most of my time right now designing solutions on top of these three pillars that you see over there. accessibility, performance, and security. Those are three concerns that are very, very important for front-end architects because they establish the base of a good enterprise architecture, right? But there is a lot more, and I'm going to show you right now what is the mind map of a front-end architect. What is in your mind all the time? So for front-end architects, they need to have knowledge, or they need to have a great overview of a system from the very infrastructure, right? And then you need to have in your mind the important integration patterns, the integrations of the code into the code base, like release cycles, like what is going to be your CI pipeline like, and stuff like this. You also need to be very concerned with the front-end setup, the technologies involved, the best way to put all the pieces together. You have to have knowledge on browser support and browser support constraints, and what are the strategies to overcome that. You need to know about standards and specifications, about protocols, about APIs, about E2E testing. And need to be very knowledgeable on security. That's a very important aspect. Obviously, nobody wants their applications to be cross-site scripted or anything like this. You need to know about authentication, about content policies, about headers, how to prevent exploits, how to better store data on the client side. And then, needless to say, you need to know about troubleshooting, about debugging, about how to access sources, how to make sure runtime performance is within budget. And when I'm talking about budget, it's not like money, it's about those kilobytes that you decide are the most effective or the least detrimental to your performance, to preserve an impeccable UX experience, right? So we have this huge list of concerns, as you have seen, that in the end we can categorize into layers. And that is more the same, if not the same, for every single project. Like every project or software project web-based in the world will more or less have these layers. Infrastructure, right, which fall more or less in the realm of the backend or system people, but a good front-end architect needs to be a little bit involved there. And you will need to have also a layer for data storage, another for the access of that data, and then finally the business logic comes on top, and then our realm, our happy place, the front end, right? So if you're purely a front end engineer, you're probably concerned or interact with the at least the top four. But like I said, if you are an architect, you need to also, have a good knowledge of the infrastructure your applications work on top of. And as you can see, one of the concerns we visualized before in the graph is micro frontends. And micro frontends are a very hot topic at the moment, and this is why I wanted to focus this presentation on, because I think nothing gets more complex at the moment than this attempt at decentralizing our applications. And we're going to see why we need to do that right now in the current historic context for software development. And I'm very sorry, this is an online talk, because I would really love to ask the audience, what do they think micro frontends are? And if they think it's a new concept, if it's been there for only a couple of years. And yeah, so let's start by getting in the same page. Like, think about micro frontends and what they mean to you, and if you think they're a new concept. If you were an internet user 20 years ago, like I was, you probably experienced a very antique flavor of micro frontends. And I don't know if you had the pleasure, but back then every single internet site had something like a weather widget. So your local newspaper, a weather widget, and I don't know, you went to a forum, a weather widget, and then you went to Yahoo or Yandex for you, and you had like 3 or 4 weather widgets. So weather widgets maybe would have qualified for micro frontend, for a type of micro frontend, because it was in the end a micro application embedded in a page. And we also had macros, we had Java applets, we had Flash movies. And so the concept of, putting small pieces of front end in a page is not really new, only that we have probably made it a lot better and a lot more normalized right now. So let's do a throwback to the early 2000s, because I want to establish a timeline on how we are where we are. I think it's much better to understand why we finally decided to split everything apart. So the problem we've been facing forever started with the very roots of web development. So what did web development look like back in the day? Maybe in the front end, it looked a bit like that in the early 2000s. And I have to say that when I take a look at these pictures, I remember how much time it took for me to accomplish the emulation of those tabs and doing those round borders. It was so much pain, and you are so lucky to have right now all the tools you have in CSS3, because back in the day it was quite an accomplishment to do something like this. So back when I started developing websites, apart from the obvious constraints with CSS, like I was telling, and images, sites were structured a lot different than they are today. So everything, HTML, CSS, JavaScript, it was more or less mixed together. And I know you may be thinking, okay, but there are some frameworks that right now, today, they favor this pattern of HTML and CSS in JS, and it's true, they do. But I think the key difference is that right now we split things at compilation time. So we may write everything together to modularize, to have all the code that is relative to a component in the same piece, and then better maintain it, or have it have a better overview of the component. But then when we do the compilation, everything gets, split and then maybe reaggregated later, but can have a different source for each one of your technologies. In the early 2000s, in a typical HTML document, you would find a lot of HTML4, which was the standard, and you would find a lot of mixed JavaScript snippets and inline CSS. And I guess at some point it was really evident that it was much more efficient to separate concerns, right? And to move CSS and JavaScript to their own external files. And that made it all much easier to debug and maintain. And that's what we did. The modularization era began. This is the story as we all know it and as we live it today, right? But even in the earlier times of modularization, for a long while, we were writing all JavaScript in one single file, like for every single component in a website, and all the CSS probably in the same file. And we were still back then in CSS1 or CSS2. There were no preprocessors, and JavaScript was probably used in the ECMAScript 5 specification, and we used a lot of jQuery and MooTools and stuff like that. But we used JavaScript mostly, to do alerts, to do not very complicated things, right? So pages were a lot more, or were more informative and static than today. But of course, sites grew bigger, like especially in enterprise, sites grew bigger, features grew rich. JavaScript was more complex, and as it got more and more complex, the structure of sites got also more and more complex because we had a lot more code to handle. So we ended up with these huge aggregated files to tell to treat the limitations of HTTP1, right? And until HTTP2 and now 3 came into the picture, and we were able to again split and do multiple requests because of how the multiplexing nature of HTTP works, and we could really say, okay, we don't need to aggregate components anymore, we can ship them individually. Well, we could not really start distributing. But now we have, if we have a component in a page and we need this component, we can lazy load it We can request that file individually, and we're not anymore concerned about filling the quota of requests that we that will bring our system down, right? So with the distribution from remote sources, we started going into the CDN. We also started pulling code from remote registries like NPM. And at the same time, JavaScript frameworks and browsers evolved in a way that allowed us to put more business logic in the client side. And again, that made JavaScript even more complex, because if before only the server, only the backend was handling those very complex operations, those very CPU consuming and memory consuming operations, now we had them in the front end, and we even had to resort to patterns like web workers and trying to in some way open threads for a language that doesn't have them, right? So let's say that this has been a more complex and more difficult road than the one I am depicting over the years. But in general, we learned lessons about separations of concerns, and keep that in your mind, separating concerns, about decoupling code, about distributing. And while in the front end, we were getting better at modularizing our code, in the backend, they were doing the same, but even one step farther. And they called it services. So these are independent capsules of business logic owned by independent teams. So if we go back to remember this layer stack from the previous slide, and we map it to a monolith that we were talking about at the beginning of the presentation, we get the classical two-tiered architecture. So when it comes to enterprise applications, let me tell you that I don't think that any modern project right now is a pure monolith. Like, I'm not talking about 5 years ago, but the projects that are started right now, I don't think any of those are a pure monolith, because we have already learned to at least decouple some services, and we are working together with APIs that are remotely hosted and usually maintained by product teams somewhere else. So we began to do that as well. We began to, in our own context, move some of the data to specialized or dedicated APIs. And that made it easier for those enterprise systems not to bloat anymore, not to fall apart from so much code. There has been this imperative need to decouple, but as long as we continue to stay attached to that two tiers kind of architecture and infrastructure, we are never going to get really out of the tight coupling game. Hence, microservices. When we realized that instead of having that large server block, that monolith, to take care of all the requests, of all the heavy operations, we could have a breakdown into multiple smaller units. But remember what we said also when we were discussing at the beginning. In order to successfully implement this breakdown, you need to map each one of these splits to a business unit or to a business capability or logical domain. So this type of architecture has great impact on something that is not technical, like I said before also. It has a great impact on teams and processes. So microservices solve problems, right? And they also introduce some other problems. And if you're splitting your backend to work in dedicated teams, it would probably make a lot of sense that you also split your front end to match it, right? So you have your service, you have your API, and then you want to keep the front end also connected and also owned by a same cross-functional team, probably. I think when it comes to enterprise scale, like we were talking before, one of the problems, and I also mentioned it the introduction, is that one of the things that we wanted to accomplish with a microservices plus micro frontends architecture is that we wanted to be more independent in our release cycles. We wanted to give those features or be able to introduce features on our own schedule, on our own plan, and not depending of a much larger structure. So you have a feature that is connected to a business domain, and this feature is being constantly maintained, let's suppose. And then you have probably another that is hardly ever maintained or is not even any longer developed. But then again, to release your dynamic capability together with that one that you never touch in this large monolith. So let's imagine this scenario to get it more clear, that a lot of people, especially in enterprise scale development, are very familiar with. So imagine you have this page, right? And part of that page of what we would call a modular monolith, because every component is a module. So based on components and services. And only a few components of this page will be worked on in this sprint. Let's imagine we are on a sprint, we are working, and they say 1, 2, and 3 are going to need some love this sprint. Maybe 1 is a new feature, 2 will need to have its JavaScript extended, and 3 needs new configurations coming from the backend, maybe even to serve some JavaScript. Typically, how you do this, if you're working in a Git flow, is that you will branch out from your default branch, be it develop or whatever you call it. And very likely, if it's a very, very large project, you will have teams to work on each one of those features. But those teams are not dedicated teams. It's like the project manager is there with you on the table. There are 3 or 4 or 5 front-end developers or whatever amount of backends, and says you and you are going to take care of this. Or maybe the tech lead says, this is a task better done by X person. But there is no ownership of any of the features. It's something that all of the team takes care of. And then when you all are done, you have to put all that code back to probably a release branch, and then put that release branch back into develop, and then finally deploy all that to the production environment. But you put everything, not only your features. You have to probably release a new version of your whole monolith. And yes, from a technical perspective, triggering a new version every time you make a few changes is a real problem. It's really exhausting, because that whole monolith needs to be completely rebuilt and redeployed. And that means that if this project has different contexts, like imagine you have sub-projects that depend on it, or some other pages or sites that don't even consume these 3 dependencies that we talked about being modified, and you bump the version for the whole monolith, you need to update that version everywhere. And that, for example, in an enterprise context, means that sub-projects will need to roll out hotfixes only for the version of the core of this product or this project. So from a people's perspective, teams will be randomly assigned to a task, like we mentioned before. And maybe in a future sprint, some other people will take care of this feature. And that means that you need to do a sort of a handover. You need to pick up from where somebody else left. That is also time consuming and costs certain investment at a time level, but also, I wouldn't say emotional level, but if you take on somebody else's development all the time, that change of context or continuous change can be somewhat exhausting. So somebody thought, okay, why not having independent teams and have independent deploys. And again, if you're working in a very large team and are able to split your system in independent development and deployment units, it may make sense, right? But remember that for this micro split or micro architecture, microservices plus micro frontends to work, we should respect these principles. There should be one and only one business domain associated with each unit. There should be an independent team owning the feature and making it their own, and making probably their own independent architecture decisions and processes choices. And there should be no shared logic between these units. So a small part should be able to fail safely. So basically, the idea behind micro frontends is the same than the one behind microservices. To have the independent teams that have a lot of freedom, that can meet the requirements of a business capability, they can decide their release schedule, they can decide their architecture, they can decide their tech stack. So in my opinion, this type of patterns works super well for products. You can think of your favorite stream service where you have probably in one URL, like you load a page and then you have a video player and then you have another component or another feature where you can see the latest releases, then another where you can see what you already watched and or have some progress on and can pick up. All those features are probably handled by different teams and it works super well. But when you are working in a user-facing website kind of project, it starts getting a little bit more complicated. If you give each independent team complete and other freedom, how do you want to do things, then how are you going to preserve the corporate identity? How you're going to preserve the state-based user experience, and how are you going to preserve the performance? It is a very difficult task to accomplish, and putting those small units together without completely destroying a seamless user experience requires that you think very well on how to do the orchestration or on the orchestration phase. So there are many ingredients to doing this right, and let's start with the first one. So when it comes to micro services plus micro frontends, I don't want to talk only about micro frontends. Big frontends need the microservices. In my opinion, you could have a monolith and then split your frontends, but it's really going to be even more complicated, right? And orchestration is a huge topic because it means that you are going to be integrating very large distributed systems into something that appears to be the same and developed by the same team. That's it. That's what you need to project, that everything was done by the same team, although it was not. So there are great tools now, yes, focusing in the front end to orchestrate micro frontends like single SPA, for example. And that helps a great deal with, for example, the routing and the composition, because the route composition are probably the two aspects that are going to cause the most pain. And this already brings us to very many micro frontends available. What technique we want to use will very much depend on the required level of encapsulation. So when the level of encapsulation is required to be high, integration is safer from a security standpoint, but it is probably less performant. And why is less performant? Because if you are more encapsulated, there are less possibilities to leverage the shared resources, like, I don't know, fonts, styles, other dependencies, and caching as well. So there is less opportunity to reutilize code. So when should you want to encapsulate more your code? If you're working with independent teams, outside of your organization. And if you are anywhere in the yellow that you see there in my screen, use iframes to completely encapsulate your code. If your performance budget is very low, and it should be if you're really concerned about abandonment and about having a good UX or user experience for your customers, for your visitors, then you probably want to think of having a more integrated strategy so you can share all the commonalities. And each technique, like I said, provides a different level of encapsulation because it's the result of a different containerization strategy. So we have the following techniques. We can have hyperlinks, which is when you basically load each application independently in a different URL. You can have iframes to load micro applications in regions of a page. You can do ES imports and load them dynamically, for example. And you can have web components, which offer a medium, we will see later in the demo, type of or kind of encapsulation, because it depends on if you use Shadow DOM or not, and how you integrate them in the page. So the container types could be an app shell, they could be an iframe, they could be a hyperlink, and this is basically what you could think of as your container for integration. Again, how these micro frontends are going to coexist in the end in a platform will have impact in your decision on how to containerize them. Want to keep them very, very separate, and there is no problem. They don't need to interact. Each one of them has a very different concern. Then go for hyperlinks. You're going to save yourself a lot of problems, but if you have to put them all together in the same page, then that's when things get more and more complicated. So apart from having each, or if you decide to have them in one page, or your requirement is to have them all coexisting in one page, apart from having a micro front-end team, or for each feature, a team, like we said before, you also will need to have a dedicated team for the container, for the shell, right? Like you can see here, that would be the team 0. It's the one that is in charge of the host runtime, the one in charge of the APIs that connect the micro frontends together, the one in charge of the events that also allow those micro frontends to come and become part of the same current, right, of something seamless. Because when you're working with micro frontends, you probably want to think of an API first, event-driven browser as an API kind of cohesion between components. You need to have a team dedicated to making that cohesion happen. And one thing you need to learn very well to do when you have them all in the same context, and you are integrating several micro frontends to that context, is to leverage and purpose the browser APIs. The applications react in the same way to events that are part of the global window object. So that's important because you're going to reduce the amount of abstraction. You can already leverage things that exist or mechanisms that exist, but obviously those mechanisms not always exist in all of the browsers, and sometimes you are going to have to polyfill for them. But for example, if you think about the history or preserving the history for the user, to happen when a user clicks on the back button, you're going to have to establish an equal mechanism for everyone. The best way to do that is, for example, use the history API and make sure that the state is preserved consistently across the many applications or micro frontends in the page. And there is another team that you will need, a dedicated UX and technical writers team, to work together with the technical implementation team to conceive a style system that everyone can follow to be more autonomous. So you don't have to have somebody overlooking and dictating. They can all go to this style system and get hints on how or what is considered a best practice, a pattern in your environment. So you need these very well documented developer guidelines and also user experience guidelines and technology definitions, because otherwise it's very complicated to provide teams with autonomy. You also need to have a very good performance strategy. You probably want to think of a performance budget, and you want to make sure that there are no collisions or duplicated requests of dependencies, and that you can now streamline the request to common assets, like we mentioned before, such as fonts, etc. You will need to think very well how you will cache all the resources, because you can ruin completely your user's experience and provoke abandonment and provoke them to just, close the browser because things look off place, they look different, they don't work in synchrony, and that's a very important aspect of connecting all micro frontends together. So how we do the structure, or how we structure better these large applications that may host code for completely independent micro applications that at the same time implement a very effective strategy of code reutilization via shared modules or assets. Well, one of the most effective patterns for that is the monorepositories pattern. Okay, and a lot of modern frameworks already offer the ability to structure your applications or your large projects with a monorepo pattern out of the CLI. So I am not very familiar with React. I am not a React developer, but I am a Google developer expert, and Angular provides this possibility. I'm sure that all other frameworks have this ability. But then again, you also can do it on your own, even if you're not using any framework, even if you're going for a vanilla JavaScript application. You can do that with LearnUp, for example. And the basic idea is to separate utilities in libraries that you can actually publish and consume from a registry, public or private, and completely decouple them from a project. So they can be effectively reutilized, while at the same time you keep the whole project overview. So obviously, while it may improve the developer experience in terms of keeping everything together or keeping overview of the whole project, and keeping the amount of necessary repositories to a minimum, you will need to consider how you build all this. So keep that part in mind. It's a bit out of the scope of this talk, but let's imagine that you need to do, and we're going to talk about it, the testing of an integration. You probably need to be able to build it, and you probably need to be able to consume it in a. That's another aspect that needs to be kept in mind by architects when defining the structure and defining whether they want to use a monorepo or they want to have separate repositories for their code. So you can also publish commonalities from independent repositories, like we said, and consume them from an external registry. The important thing is that you are able to identify everything that is a commons that does not belong inside of the component, and be able to abstract it away. So nothing that is a utility or a wrapper function or a helper or anything like that should be inside of the components. Everything should be abstracted away. That may mean that in the end you will have a very large you're consuming from, but that's okay, because the idea is to reutilize as much as possible and to keep things connected. So not only JavaScript, but also CSS abstracts. This is something that some people never thought about. You can completely package all your abstracts, all your mixins, all your utilities for JavaScript, for CSS functions, etc. Especially if you're using a preprocessor or post CSS, you can also package that and publish it where many teams can reutilize and establish a better strategy for cohesion. And of course, when you have a very aggressive abstraction and when you consume from heavily, and who doesn't, you will want to have a very well-designed code splitting and tree shaking strategy, because tree shaking is essential to prevent code duplication. And ever since Webpack 4, we have the ability even to flag our modules when they are pure, and they can be safely pruned using the side effect flag in the configuration. So you can say, okay, if we get rid of this code because nobody's using it, nothing will happen. Our application will not break. And those are best practices that we need to get used to implementing, also for the benefit of all those distributed teams that we may be working with. We need to leave that mentality of everything is here in the house and everybody is close to me and I can talk to everybody. Rather, talk to them with your code and the best practices you implement in your code. Another reason to have a very good code splitting strategy is the possibility of better implementing lazy loading mechanisms for anything that is rendered below the fold in a page. So especially media assets, but also other assets like JavaScript and CSS in a whole component in itself. So for assets like CSS and JavaScript, the trend is more and more to inline resources above the fold. So that grants you a very super fast rendering, and it makes sense since we need to prevent the mentioned before. Well, I think I changed the order of the slides. I was going to talk about performance first, but I think this is a good introduction. When I mention a cumulative layout shift, this is a new metric by Google that we're going to explore in a moment. And keeping anything below the fold as a lazy loaded or as lazily integrated module, while you inline every asset in the above the fold, will help you prevent a cumulative layout shift. Another very important concern when you are enabling independent teams to make their own decisions in terms of technologies and frameworks is state management. So the idea of having independent teams deciding their stack sounds super appealing. And I think this is one of the selling points of micro frontends. Like one team can use Angular, another one Vue, and another one Svelte, and another one React, and so on. But even if that's super cool because it offers you no vendor lockdown, no migrating a whole monolith from one technology to another when it gets obsolete, etc., how do you deal with state management? Because I think everyone watching this talk will think it's crazy if you put Redux and NGRX and Vuex and whatever other state management system middleware on top of your application and try to connect everything together. I never tried to do that. I had experience connecting Vuex with a Redux store, but I can't even imagine trying to mix every flavor together in one single layer. So one mechanism we could use to simplify the storage of state when we have multiple technologies could be an event-based publication and subscription system, or event pass. So leveraging client-side storage methods like, I don't know, cookies or local storage. Of course, there is no persistence to the state. Once the session is closed or the user cleans the cache, or it's gone. But it serves very well the purpose of communicating during the interaction with the user. So it's usually a singleton publication subscription module could be very, very reduced in size, like less than 10 kilobytes, and it serves this purpose really well. We will see it in a moment. So when do we want to use micro frontends? Let's see some graphics to help us decide. For me, this boils down to the following graphic representation. Where in this graphic team and project, for a large existing project, for example, if your backend is very, very monolithic and you have very frequent release cycles, and you are somewhere in the yellow rectangle, you probably don't want to migrate to a microservices or micro frontends architecture. If you have a single team, they don't own a feature and there is no possibility to change your the mindset of your organization into having different business units that want to own a different feature, and you can change that, you probably don't want to go with microservices or micro frontends. If your team size is small and the nature of your project is to serve static rather than dynamic content, you probably also don't want to go with micro frontends. And if the applications you want to decentralize are very large and it's not possible for you to use, for example, a technique called module federation that we're going to see, you may not want to go the micro frontend route. Also, if you want to stick to a vendor or certain patterns, but you don't want to have, or you don't have the budget to write very good style guides and developer documentation, and there is no plan to stick to one, streamlining method for letting everyone be in the same page, you may want to reconsider going in the micro frontends direction. Of course, the mechanism you choose may also have to do with the browser you're supporting. Granted, there are polyfills in most cases. You have to remember that polyfills are data over the wire that may impact, or not may, that will impact your performance. And this is a screenshot from Can I Use, where you can see, for example, if you want to use Shadow DOM but still have to support Internet Explorer 11, which is very much still supported in nice contexts, you will need to polyfill it. If you want to use custom elements as well, if you want to use JavaScript modules as well, if you want to use dynamic imports, you also have to polyfill. But even with all those downsides, I personally feel that microservices and micro frontends, especially cloud-based, open new avenues for teams to become more cost-effective and focus and have a lot of fun, because there maybe if they have the opportunity to decide what technologies they want to work on, they are going to have a lot more fun than if they have to follow some established rules. So basically, the team configuration aspect is incredibly important, and we probably need to be talking about a very, very large project, again, with independent vendors or third-party providers for micro frontends, particularly to make sense in a context in enterprise. Or, again, a product that has very well-defined business domains, and they can assign a team to each one of those capabilities. But then again, there is another experience that is a lot more important than the one of the developers, and it's the user experience. And the paramount of great user experience is nothing other than runtime performance. And I am sure everyone is or should be concerned about achieving great performance. And one of the ways of knowing if you are on the right path is to take a look at these three metrics that were out this year by Google. One is the LCP, another one is the FID, so it's largest contentful paint. FID stands for first input delay, or the delay from going back to the server and coming back after a user inputs or an event is triggered from the user input. And the most important, I think, for me in this case is a cumulative layout shift. And the cumulative layout shift is a factor that increases relative to how things are displaced, or how objects or elements are displaced during the load. So if you have, for example, a large contentful paint, which is a stage, for example, and it loads, and when it finishes loading, it pushes content down, that's going to play against your cumulative layout shift, and you're going to be penalized by Google. And you know that when they penalize you for performance, that has an impact in your indexing, in your SEO. So this is a very important part of the overall architecture strategy. I think I am a little bit late. I think I have 10 more minutes and I want to do a demo, but I wanted to talk a little bit very quickly about the difference between client-side rendering, which is the regular way of loading all those applications that are in a front-end or micro front-end format, which has these metrics results. So they have a very slow time to interactive. The server-side rendering has equally slow time to interactive, because not only you have to bring everything from the server, but then you have to bootstrap the application on top, and it requires also a very special infrastructure to make this happen, and to take duplication. And then we have the latest trend, which is server-side generators, static-side generators, which are great, yes, they are fast and they give you great results in terms of performance. But of course, you need to consider if you want to go in this direction, because depending on, especially in an enterprise context, if you have a lot of pages to generate, a lot of HTML to generate, then it's going to probably take several hours, if not days, to do the full generation. And static site generators are very linked to the Jamstack. I think the Jamstack, even if it has been around for 5 years, it has definitely gained traction in the past too. And it's a collection of best practices and guidelines on how to do web development, or the whole web development cycle and deployment and the integration, and how all assets should come from CDN, how deploys should be atomic and a full snapshot, how the cache should be invalidated after each deploy, so we get a consistent versioning, and how everything lives in Git, and how, again, build automated and the continuous deployment and continuous integration strategies are very well designed. And this happens mostly there are other things that are happening right now in the cloud that are important at the time of designing a very good JavaScript architecture. And even when you may think infrastructure does not, or is not relevant to me, it does not play a role on how I architect my JavaScript applications. That's really not true, because you get so much from the cloud at the moment. And I can tell you from experience that we have completely ridden ourselves from very complex backend systems by leveraging serverless functions, for example, to deliver API endpoints. So you can have a full Apollo GraphQL client working on a serverless function, and the cost is very effective, because it only creates a cost when it runs, and that makes it a very good opportunity for especially small agencies to get in the game of enterprise development in a comprehensive way. So you can offer your front-end applications, and you can offer also the APIs that run them, and you can write them in the languages like Node.js, like TypeScript. So everything is more or less, or the boundaries are more or less diffusing in today's architecture patterns. So now, yes, finally to module federation. So let's go back to this scenario where we have a host app, which defines the first Webpack runtime to be initialized. Please notice that the role of being a host, because in module federation, the basic is that you have a host and that you have a remote or a bunch of remotes that you want to bring into this host. And those remotes are essentially and literally in remote locations. But what defines the role, what defines the being a host or a remote at any given time is that hosts initialize their runtime first. So it's interchangeable. If you are in a page, one of the containers can be the host and bring all the other remotes. If you are in another page, maybe one of those that were previously a remote will become a host. So each application is bundled independently and they require to be configured in a certain way. And for example, this is the configuration of a host in this case, and we see that. Let me see because it's not okay. It's in the wrong number of the highlight. I probably added something more, but what I wanted to show you is that this is exposing a set of shared dependencies that we want to provide to any remote that is going to be initialized in our context. If we have, for example, if we're bringing Angular remotes and I have an Angular in my page as a host, probably we don't want to load Angular twice because that doesn't make any sense. And if we have other dependencies that we're sharing, we probably also don't want to load them twice or to even request them twice. And okay, 1 second. Okay, and now this is the configuration of the remote. As you can see, it's the same because, again, those two can be interchangeable. The only thing that may differ is if you are a host, like you can see here, you are defining which are your remotes, which will create a different scope for each one of them. So if you see their remotes, you have remote 1, and that creates a scope for this new application that you're going to bring into your system. Whereas in the remote configuration, you may not have any remotes coming in, but you are exposing a module. In this, let me see if I did the highlighting correctly here. In this case, this remote is exposing this module. This is the public name, the module, and then you have to map it to the internal request on the remote side. And this file name that we see here, remote entry.js, is not the bundle. This is like a loader that is about 3 kilobytes in size that initialize the runtime or the or will initialize the context for the remote to be brought over. And finally, this is a little bit how it works. Then in the end, so you have the host runtime, you have the remote container, the remote exposes modules, both may be providing their own dependencies and consuming dependencies. What is important is there is also a version definition and a version check upon consumption of those modules. And now I want to take a moment to stop sharing. Let me, I think, 7 minutes. Let me change. I'm going to have to change what I'm sharing at the moment. So please give me a few moments while I figure this out. Vasily, any questions?
Yes, but I don't want to interrupt you while you set up your sharing. And after that, I have a ton of questions. I have a sheet of paper and I'm already moved to another side of it.
Okay. Okay, so because I think I when I get so excited about a topic, I extend myself a bit, so we have a little time for this demo. But anyway, it's not super complicated. What I wanted to show you is like, for example, here I have a Lerna mono repository. I do it in this way because it's easier to have all the code together. And what you can see is I have a host, and I have here two micro applications, micro application 1 and 2. They are Angular applications. The only difference is that this is a regular application, and this one here is a web component. Okay, that is standalone. So it bundles everything, even the polyfills and the Angular core and everything that Angular needs to run. And so you can see them here. This is the host, and my requirement was, or this hypothetical requirement, is that we have a page where we have micro frontends integrated in different ways, like, for example, an iframe. And that's not new. Everybody, I'm sure, has done it more than once, integrating an application in a region of a page in an iframe. And I want to be or do a little bit of myth buster here, because people hate iframes. Iframes are a very old solution, but they're very well supported solution. And when it comes to and making sure that you safely integrate code from remote sources, I think they are unbeatable. So don't hate iframes. They have a purpose, and yeah, they're there for a reason still. So here I have integrated, you can see it in the HTML. I am just, where is it? Over here. Hello, micro frontends. I am just calling this iframe, this source. It's my application living here in 14.02. Obviously, I have enabled CORS because otherwise you can never do this. And you can see if I click here, this, which is my application, is reacting because I have an event bus. I am doing window parent post message, and I am publishing a topic from the iframe or from the application in the iframe to be listened to. Is my host is subscribing to this, and then they can communicate, and this can send messages. So imagine you have, I don't know, a shopping cart that is developed by a different team, and you still want to keep the count of items in the cart, the information. You can enable that communication. And then what we are going to do is we're going to federate this web component that I have here. Over here, I'm going to uncomment because, yes, we want to do this as fast as possible. So what I'm doing here is, as you can see, calling this remote entry. Let me uncomment it. So what I'm calling is from the 4202, this remote entry. JS, like we said, this is not the bundle. This is the loading script. And in order to have it working, we're going to go then to the host Webpack, and we're going to type a few items that we needed to work. Obviously, again, Webpack 5, right? This is not available else, only Webpack 5 that was released about 1 month ago. Bleeding edge, keep it in mind, there are some modules that have not yet been upgraded or are not, here dependencies are not compatible with Webpack 5. I think it's going to get better in a couple of months. But we're going to start typing the properties that we need. We need to give this host a name. We're going to call it host app. We're also going to want to define a remote. And the remote is an object, and we're going to call it, of course I have it over there because I don't want to mess it up. In our case, we're going to give this remote scope the name of MFE2, microfrontend 2. And then we're also going to add this. This is apparently going to be optional, but for now, we're still going to add it because I don't want to mess our demo. So the type of the library is a variable, and the name again is host app. And we have to define the file name, which again is remote entry.js. And we're going to say that we're going to share, in this case, this is the publication subscription module, because I am working locally, and if I try to call it by name or define it by name, it's going to tell me that it's not available for your consumption. So what we're going to do is we're going to copy from the package.json the location. Again, this is only because I'm working locally, okay? So if this was published, obviously we don't need to do it in this way. So let me see that is all okay. I don't want it to break. Okay, looks good to me. And then we're going to go to the micro application and we're going to do the same. We're going to give it a name for the scope. It's going to be microfrontend 2. Let's, for the sake of brevity, copy this. Sorry, it's not yet. This and exposes. And in my case, what I'm going to expose is I'm going to give it the public name of element. And I'm going to point at the street where all this is bundled. Again, this is a standalone web component. So this is not, you need to enter a different kind of command to make sure that everything compiles in a single file and that you're able to call it from the source. I'm going to show you how I compile this. So in my case, this is source app. I could do it from distribution, but let's do it in this way to make sure, because it's much easier to get this absolute path than going to the distribution folder. JS, and then we're going to again grab the shared from here and add it over here. Okay, I think it looks good. And now I'm going to reload this page for you to see that it's not there. And you can see it also in the HTML. But then I'm going to bring my where is it? My terminal. I'm going to kill the server, and I'm going to run the build. So Webpack runs. You see I'm on 5.5. It compiles successfully. Okay, I'm going to restart the server. And if I reload, nothing is happening because let me bring this over here. Probably it requested this, but it's not finding it. There is nothing over here. Micro frontend, okay, it is there. Let's kill this one. And compile it. This is MyProp 1, this is MyProp 2. I should have it. Okay, this is not the one, but have it here so I can copy it and paste it. This it's going to output a standalone Angular element. It's generating the bundles. Remember, I also have Webpack 5 in my Angular application. I'm running Angular 11. It's an experimental optional feature. And I am also using a dedicated or custom filter. Okay, what's going on?
Natalia,
This is
sorry, I
something
have
that
a
you
great
should.
proposal.
Yeah.
We almost out of time, so I suppose we can wrap up and we can continue that pretty interesting example in our Zoom chat. I mean,
Okay, yeah. Sure,
there
sure.
we are free about time, about our opportunities and so on. And more than that, I suppose people who are interested in, especially if they'd like to ask any questions about config you presented, they can join us and even talk with us in voice. Ruslan, what do you
Yeah,
think?
sure.
Yeah, I guess that's a
Yeah,
great
yeah.
idea, and we actually have like 2 minutes more because like the timer you see is made for my entrance to the broadcast, so it's fine. But I guess that the idea of going into Zoom with the end of the examples and with the possibility for people to ask questions in person in Zoom is much better than doing all that stuff. So, and as far as I understand, Vasily has a ton of questions more over the topic you've covered already. So I guess we can tell everyone who will stay with us for the closing of the day ceremony to say goodbye. And if someone wants to continue watching Natalia's talk, you can go to the Zoom room, which is located in the, like, there, yeah? Somewhere there under the player. Right under the Natalia, just click the link, go to the Zoom. It will start working as soon as we will put Vasily as a co-host. And Natalia, thank you. Vasily, thank you again. That was a great talk, and I guess we can start moving to our closing ceremony. Bye.
Okay.
Nice. Natalia, I'm waiting you in Zoom.
Okay, so I have to also move to this presentation, right?
Yep, there you can share your screen and present all that stuff you presented before.
Okay. Okay.
So,
so I
yeah.
moved to a different Zoom talk.
Yep.
Yeah, okay. I'll try to find the link. Thank you.
So I guess I can be alone here.